Everybody, we're going to go over some review material from your advanced chemistry class, your sophomore year. Most of you have taken it. This is just some of those key pieces of information like Sig Figs, scientific notation, adding and subtracting, multiplying and dividing the Sig Figs that you need to go over and you need to know for AP chemistry, but we might not have enough time to actually go over this specifically in class. So if you don't understand anything, you don't remember stuff, please remember, don't hesitate to come in for tutoring or anything like that. So first off, when you're counting Sig Figs, what you want to remember, there's two main rules for counting Sig Figs. First off, you're going to start counting at a non-zero number. And then that's where you're going to start your counting. Once you start counting, you keep counting and you count everything, including the zeros. Now, the big thing is, which side of the number do you start counting on? Because that's going to be the most important part here. So kind of use a little bit of geography here. We've got our Pacific Ocean on this side. We have our Atlantic Ocean on this side. Pacific is for present. So if there is a decimal point present, you're going to start counting on the left side of the number. You're going to start counting at the first non-zero, and then you're going to keep counting. If there is no decimal point, if it's absent, like Atlantic, then you're going to start counting on the right side. Again, go to your first non-zero number, start counting, and keep counting. So some examples here, we've got 350. We start on this side of the number because there's no decimal point. You go to your first non-zero, start counting, and keep counting. So that has two Sig Figs. Next, we've got 0.0020. We start on the left side of the number because there is a decimal point present. You go to your first non-zero, start counting, and keep counting. So this one has two Sig Figs as well. Next, we've got 17,500, no decimal point, so you can start counting on the right side. Go to your first non-zero, start counting, and keep counting. So this one has three Sig Figs. We've got 27.02. There is a decimal point present. We start counting on the left side, start counting, keep counting. This number has four significant figures. Next, we have 135.0. There is a decimal point present, so we start counting on the left side. We go to our first non-zero, start counting, and keep counting. So that zero is significant here, so that has four significant figures. And then our last number, 2060, there's no decimal point, which means we start on the right side of the number, go to our first non-zero, start counting, and keep counting. So this number has three significant figures. When you're rounding, you want to go to the first number on the left side, the first non-zero number on the left side, and go to the digit you want to round to. This is the point that you round to. You want to maintain the value of the number. Okay, so if you have 25,360, you want to make sure you keep a number around 25,000 once you round your number. Okay, so that's why it says if you have numbers before the decimal, you're going to convert those numbers to zero, so that way they are not significant anymore, but those zeros are still maintaining the value of the number. If you have numbers after the decimal point, you have to drop those numbers. You're not going to turn those ones to zero because we do not want those to be significant. So here, if we're going to round these to two significant figures each, this is our second significant digit. We have 120,320. To maintain the value of the number, we would want to round this to 120,000. A lot of students would just want to put 12 so that there's just two Sig Figs, but you have to maintain the value of the number. This one we want to round to two Sig Figs. We go to the second significant figure from the left, which is the 6. We look at the number to the right of that. That's going to tell us what to do with the 6. Since that's a 5, we're going to round up, and we would have 0.0027. And then lastly, we want to round to two significant figures. That's our second significant digit right here. The 3 tells us that the 5 is going to stay a 5. And so it would be 7,500 that we would report as our answer. What's this? Okay, so remember there are different rules for adding and subtracting numbers as they are for multiplying and dividing. So when you're adding and subtracting numbers, you're looking specifically at the numbers behind the decimal point. Whichever value you are adding or subtracting with that has the least number of numbers after the decimal, that's how many numbers are going to be after the decimal point in your answer. When you're multiplying and dividing, you look at the total number of sig figs. Whichever value has the least amount of sig figs present is how many sig figs will be in your answer. So let's take a look here. This first number, how many sig figs does that have? It should just have 3. This middle number here, how many sig figs does that have? It should be 5. And then this last number, how many sig figs? It should be 2. We want to calculate the following. Again, make sure you're paying attention to the amount or the kind of math that you're doing. This one we are dividing, so we're looking at whichever value has the fewest total sig figs. This has 3 sig figs. This has 4 sig figs. So we would want to round our answer so that it has 3 significant figures, 0.240. That 0 has to be there because we have to have 3 significant figures in our answer. Next, we have 17.3 plus 2.785. So we are adding this time. So we're looking at the numbers after the decimal point. This one only has 1 number after the decimal. This one has 3 numbers after the decimal. So we want to have just 1 number after the decimal point in our answer. And so we would record our answer as 20.1 grams. And then lastly, we are going to be multiplying. So again, we're looking at whichever value has the fewest amount of sig figs. Our first number has 2 sig figs. This one has 3 sig figs, which means our answer should only have 2 significant figures. And we would round our answer to 6.7. Next, we are going to go into scientific notation. This is how we record numbers that are very large or very small. Remember though, when you put numbers in scientific notation, you want to maintain the correct amount of sig figs. So the sig figs are only the numbers that are before the time sign. Okay, the times 10 to that doesn't change the amount of sig figs. So here when we have 3.50 times 10 to the 23rd, that means we have 3 significant figures because we're looking in front of the times. When we have 5.0 times 10 to the negative 4, that one has 2 significant figures because that's what's in front of the times. And then we've got 3 times 10 to the negative 4, so that one only has 1 significant figure. You want to remember that if you have a positive exponent, that means you have a very large number. That number is greater than 1. Negative exponents mean that they're very small numbers, and our number is less than 1. The number of your exponent is how many times the decimal point was moved. Okay, so here on our first value here, we want to make sure that we have a number between 1 and 10 in front of our decimal point, or sorry, in front of our time sign. So we want to move our number behind the 1. So 1, 2, 3, 4. This is going to be 1.2 times 10 to the negative 4. It's negative because this number is less than 1. Over here, we want to move our decimal behind the first non-zero number. So this is going to become 1 times 10 to the 3. This one is positive because this value is large. Now, again, we want to make sure we keep the same number of sig figs, so we do not put 0.000 here because that has 4 significant figures. This value only has 1 significant figure. If you're going from scientific notation into standard notation, make sure you're paying attention to the sign on your exponent, and that's going to tell you if you're making a large number or a small number. So if you have a positive exponent like this first example here, that means you're going to move your decimal point to the right because you want to make a larger number. So this would be 490. If you have a negative exponent, that means you're moving your decimal point to the left because you're making a smaller number. So I would move my decimal point 2 times to the left to make 0.0375. Next, metric conversions. You may or may not be super familiar with metric conversions. The ones that are highlighted in red are the ones that are more commonly seen on the AP test. So just FYI on that. This first part here is a little saying that helps you remember the order of the metric conversion. So Kingwood High does. This bracketed area here represents your base unit. That could be meters, it could be grams, it could be liters, it could be volts, it could be any kind of unit here. During class Monday, notice it has dots, maybe naps. So those words, those sayings go with these prefixes: kilo, hecta, deca, meter, liter, gram. Those are the base units. Deci, centi, milli, micro, and nano. So most of these are just the first letter. This is like a K, represented with a K. This is represented by an M. This is represented by a C. And this is represented by an N. Micro is fancy. It's this little thing here, but you usually don't see that one represented a lot on the AP test. When you're going from kilo to milli, everything is a difference of 10. So 10 to the third, 10 to the second, 10 to the first, all the way down to 10 to the -3 for milli. There's a lot of milliliters, for example, in 1 liter. This dot means that there's like a little jump. Notice it goes from -3 to -6 to -9. So a nanometer is a lot smaller than a meter. There's 10 times 10 to the 9th nanometers in 1 meter. The only time you're going to see a nano is when we're talking about wave calculations. And then let's just talk about density really quick. The formula for density is density equals mass divided by volume. So it's a ratio of the mass of an object per its unit of volume. Sometimes you will see these cubic centimeters here as the unit. I want you to remember that a cubic centimeter is the same as a milliliter. So we use those interchangeably. So we have this question: an unknown metal having a mass of 287.8 grams was added. It says it had a graduated cylinder that had a certain amount of water. When you added the metal, it raised the water level. What's the density of the metal? So the first thing that you want to do is find out how much water was displaced. So you want to subtract those two volumes so that you can find out the volume of your object. Okay? Because this is the ending volume of water, this is the beginning volume of water, this is the volume of your object. Once you get the volume of your object, then you can plug it into your density formula. Density equals mass divided by volume. So you have your mass, you have your volume, you're dividing. So your sig figs are based off of whichever one of these values has the least amount of sig figs. In this case, they both have 4 sig figs. So your answer should have 4 sig figs. You want to make sure you put units on all of your answers. So our answer would be 11.34 grams per milliliter. Lastly, just algebra, you're going to have to rearrange equations. So make sure you are familiar and comfortable with rearranging equations. If I want to solve for x here, another way of looking at this is x times x, which is x squared. So you would multiply these two values first, and then you would take the square root of that. Okay, so that means x squared is equal to, my calculator down, sorry. 5 times 10 to the negative 5 times 10 to the negative 5 times 0.5, 2.5, I should have known that without my calculator, times 10 to the negative 5. And then that should be a 5 here. And then we want to square root that. And x would be 0.005. This one, we've got x times 2x equals 3.2 times 10 to the negative 8. Another way to write this over here on the left is 2x squared. So you're going to want to divide both sides by 2 first. So we would have 3.2 times 10 to the negative 8 divided by 2. So x squared is equal to 1.6 times 10 to the negative 8. And then you would square root both sides to get x by itself. And our answer would be 1.3 times 10 to the negative 4. Why 1.3? Well, we only get 2 sig figs because of the values that went into that calculation. So those are all of your background math topics. If you have any questions, don't hesitate to reach out at any point. And yeah, I guess we'll talk later.